Last lesson was all definitions based, and although we have a few definitions today, we will be doing some calculations. And we will be specifically calculating confidence intervals. But let's go to definitions first. When I ask you to find a point estimator, I'm asking you to find the type of statistic. So is it either a mean or is it a proportion? Remember, mean is just the average of your data, while a proportion is a fraction that can be written as percent in relation to the whole. When I ask you to find the point estimate, you're finding the actual numerical value of either the mean or the proportion. So, and then margin of error, when you sample a population and you get the average or the proportion of that sample, it's not actually going to tell you what the population's mean or proportion will actually be. There will be some error involved. And so the margin of error is the limit on how much the responses of that sample would differ from the responses of the actual population. So for instance, if I took a poll to see how many people would vote for candidate A versus candidate B, and I said candidate A would get 43% of the vote, give or take 3%, what we're saying is on election day, there's a good chance that candidate A could, their actual percent, the percent of votes that, or the percent of people that would vote for candidate A could be between 40% and 46%, because you're taking 3 away from 43 and adding 3 from 43. Okay, we'll see that in a little bit. In fact, let me put it right here. So confidence intervals, the interval is always your point, oops, I can't even write or spell. You always take your point estimate, so remember that's the numerical value, and you add or subtract whatever that margin of error is to find the interval. And that interval just tells you where the population's mean or proportion will likely fall under. So when we calculate confidence intervals, we actually have a chart to help us know how confident we can be that the population, the actual population mean or proportion will fall in that interval based on the numbers we use to find the margin of error. So if we want to be 90% confident, we use the number 1.645. If we want to be 95% confident, we use 1.96. And if we want to be 99% confident, we use the number 2.576. So this is called a critical value. That's what that little Z star stands for. So here is the way you calculate a confidence interval for means. The way you'll calculate it, so this X bar, I'm going to write this down here, represents the point estimate, which the point estimate for a mean would just be the sample's mean. So you take the sample's mean and you add or subtract, and then all of this right here represents the margin of error. This is how you calculate the margin of error. So you take that critical value, so one of these values, and you multiply it by the sigma, if you remember a couple lessons ago, means the standard deviation. And then you divide that by the square root of your sample size. So n represents sample size. Same thing with this one right here is the way you calculate margin of error for proportions. So the little p hat, we call it p hat, represents your sample proportion. And so you take that point estimate, in this case the sample proportion, add or subtract the critical value multiplied by the square root of the sample proportion times 1 minus the sample proportion. Oh, there should be a parenthesis in there. All of that over the sample size. So n still stands for sample size. All right, let's start working through these. First, we're going to go ahead and identify point estimator, point estimate, and margin of error. So estimator, estimate, and the error, margin of error. I'm just not writing out the full phrase. So in this case, they'll give you some information. So in this one, we've got a nutritionist wants to determine the average number of calories in the sandwiches at a local restaurant. She samples 14 sandwiches and finds that for a 95% confidence interval, the mean is 550 to 890 calories. So this actually right here represents your confidence interval. This is really important. And so is this right here, because the mean actually tells you what type of statistic we're using. In this case, we're using a mean. It's not a proportion, it's a mean. So that's what an estimator means. The estimate is to find the point estimate, if your confidence interval is going from 550 to 890, I don't know why I put that parenthesis there, then the point estimate is always halfway between. So to find the point estimate, you're going to add those two together, divide by 2 because you're averaging them. You're finding the exact middle. And when you calculate that, you get 720. And then the margin of error is just the distance you would have to travel from 720, because 720 is right in the middle of those two. So you're just finding the distance 720 is from either one of those. So I usually just subtract the smaller number from the point estimate, and it tells you the distance, which is 170. So that means I'd have to add 170 to 720 to get 890, and subtract 170 from 720 to get 550. So you're adding or subtracting that to get the confidence interval. Let's go to another one. Our estimator for the following problem. So a financial officer for a company wants to estimate the percent of accounts receivable that are more than 30 days overdue. He surveys 500 accounts and finds that a 95% confidence interval for the proportion of accounts overdue is 0.125 to 0.230. Now they tell you over here that the point estimator is a proportion. They will put it in the wording somewhere. So we know this one's a proportion. If you recall, the point estimate is always right in the middle. So I'm going to take that 0.125, add it to the 0.230, and then divide it by 2. And I end up with 0.1775. And then, as you recall, the margin of error is just the distance from this point estimate from either one of these numbers. So I'm going to go ahead and just take the point estimate and subtract the lower bound, 0.125 right here. And that will give me my margin of error of 0.0525. So that's what you'd add or subtract to the point estimate to build this confidence interval. All right, next one. In a survey about credit card debt, the mean, that's important, the mean amount of credit card debt for a college student, for all college students is in Illinois, is between $316.10 and $375.90 for a 90% confidence interval. So let's go to estimator. I already highlighted the estimator because the type that we're using in this case is a mean, the type of statistic. The estimate is going to be the exact halfway point of these two values. So if I add 316.10 to 375.9, divide it by 2, and since this is a dollar amount, I'm going to go ahead and keep it in dollar amount. I'll get $346. Then we'll go to the margin of error, which I'll just take my point estimate that I just found and subtract the lower bound. You could take the upper bound and subtract the point estimate because you're just trying to find the distance from one of the two sides, because they will be the same since you found the exact center. And there you go. All right, last one in this case. So a student polls her school to see if students in the school district are for or against the new legislation regarding school uniforms. She estimates with a 90% confidence interval that the proportion of students, there's an important word, the proportion of students against the new legislation is between 77.31% and 82.61%. What is the point estimator, and so on. I'm actually, rather than writing them, I should have done this earlier, I'm just going to write it right underneath each question. So the estimator I noticed was proportion because they told us. The point estimate I can find by adding the 2% and then dividing by 2, which would give me right on 80%. I love that. And then the margin of error would just be the 80% minus the 77.31%, which is 2.69%. So you're adding or subtracting 2.69% to our point estimate, which is 80%, to get our confidence interval.